So moving on, unit 9. We're gonna take what was 2-dimensional. We just got done finding areas, and we're gonna make it 3-dimensional, and we're gonna find volumes. You are going to have a little bit of an imagination here. Do you have an imagination?
Yes.
Okay. I always bring up Inside Out. Do you remember like Imagination Land? Anyway, I always try to be silly about it. So, and I have a little picture here to help fuel your imagination, but here's what's going to happen. We're going to draw the base of the structure, and you're going to have to imagine shapes popping up out of the paper. Do you remember pop-up books when you were a kid, or is that still a thing, or is that from the 90s? Remember you'd open a book and something pops up at you? Okay. The shapes will be things you can find the areas of, like semicircles and rectangles and squares and triangles. The good thing about these ones is you won't have to just guess if it's dx or dy, or not guess, but like try to figure it out. They come right out and tell you. If your cross sections are perpendicular to the x-axis, it's dx. If they are perpendicular to the y-axis, it's dy. They will come right out and tell you. You will know if it is right side up or sideways. So that's the one kind of nice thing. I know, right? That's nice. They just go ahead and tell you. So here's what these are going to look like, and you have to sort of use your imagination. If you have if you have a circular base on your paper, all you're going to see is a circle. If your cross sections are triangular, do you see these triangular cross sections popping up out? And this is so cool. We're going to find the volume of something like that. It's neat. Get on board. It's neat, guys. This is literally how 3D printers work. You know how they do a slice at a time? And then you add up all the slices and you get the volume? You guys are going to be 3D printers.
Yay.
Cool, neat.
That's exciting. Oh.
So here the base is circular, and this time rectangles are popping up out of the paper at you, creating this 3-dimensional thing, which we can find the volume of. It's cool. It is cool.
It's like the Riemann sum.
It is. It's Riemann sums. Exactly. It's exactly what it is.
The triangles like coming down from the rectangle, and the
so I can't like zoom in on this. Let me Ooh, whoops, I bumped it. That was your fault.
No, we just need to get it.
Here we go. They're still rectangles. They're just super, super tiny.
Oh.
And then these are more like, do you?
Yes.
I don't know. I'm a better way of saying it. But anyway, that's what we're going to be finding. So let's go ahead and try one. The base of a solid is bounded by. Now, I will tell you that when it's written this way, it messes everybody up. So if you want to rewrite that as 1 minus 1/4 x squared, for some reason, this is fine. And this messes everyone up. And me too. I like it written better this way. So it's going to be a parabola. It's going to be upside down, and it's going to be moved up 1. So you can start at 0, 1. And I would only plug in even numbers because there's that 1/4 in there. So let's try and plug into, you can plug in 1 if you want, but it's not going to turn out to a whole number. All right, if we plug in 2 squared, 4 times the 4th is 1, and 1 minus 1 is 0. And then you get the buy one, get 1 point on the other side. So it's a parabola that's really widened out. Do you remember vertical shrink by a 4th? Like an elephant came by and sat on it, got stretched out. Do you remember when that was the topic you were learning? That was it. All right. And the x-axis and the y-axis. So the base of our shape is this right here. Now, I usually get asked, hey, Ms. Cole, why isn't it this one? It actually could be. They're the same amount of space, but why would you pick the negative one if you have a choice? Okay, pick the positive one. Now, you're going to have to imagine, use your imagination, cross sections that are squares popping up out of the paper. I can't create them for you. You have to imagine them popping up out of the paper perpendicular to the x-axis. So like a loaf of sliced bread, you have all of these squares popping up out of the paper, except there's an infinite number of slices. It's like a loaf of bread you will never run out of. Okay. Now what we're going to do is remove one slice from the loaf of bread and set it off to the side. So draw yourself a square. It says that they're squares. Oh, and I drew it in there, but did you catch this perpendicular to the x-axis? It means it's going to be a dx problem. So we know right away it's right side up. Now, if you want to use a different color or highlight, this, like where the slices are, matches up with the base of your shape. It will always be the base of your shape. So just like we did on the quiz review, how it was upper minus lower or right minus left, if it's sideways, the base of your shape in this case is going to be upper minus lower because it's right side up. Exactly like you did on the quiz review. You all did a really good job on it, so just do that again. The base of your shape will be this one minus, what's the lower one? You're overthinking it. It's the axis, so it's 0, okay? So it's actually just the upper graph, which is this one right here, 1 minus 1/4 x squared. Minus 0. Do you get how it's minus nothing because it's the axis? I think you guys all kind of overthought that. 0. Okay, it's not. Now, take what you know about squares. If that's the base, it's also the height. And now we're ready to set up our integral. So draw an integral symbol. They need to be x values because it's a dx problem. So look at your picture. We're going to integrate from where to where? 0 to 2. Leave a space and put dx. Inside of there, you put the area of your shape. Whatever the area of your shape is. So you need to know how to find the areas of squares, rectangles, triangles, but you guys all know how to do that. Area of a square. Yeah, base times height. Yes, but we're going to do this one by hand, so I wrote it twice. If it seems reasonable to do by hand, we're going to work it out. If it seems like a complete mess, I'm going to pull up Desmos and we'll type it in the calculator. So we have to do a little bit of algebra, but I believe in you guys. And multiply those together. So I'll walk you through it. 1 times 1. 1, good job. Now we're going to do the outsides and the insides together if you want to draw your little rainbows. The outsides give you minus 1/4 x squared. The insides also give you minus 1/4 x squared. So if you minus 1/4 and then minus another 1/4, you have minus 1/2 x squared. Good job. Think of it like you lost a quarter and then you lost another quarter, so you lost 50 cents. Get what I'm saying? All right. And then the last, negative 1/4 x squared times negative 1/4 x squared. Where first of all, negatives cancel, so it's going to be plus. What do you think? A 16th, good job. X to the 4th, good job. So we had to stop and do some algebra. Now we're going to do exactly like you did on your quiz review. It's antiderivative, upper minus lower, and we'll just leave it alone. So what's your antiderivative of just 1? Just x. But it could be y if it was a dy problem, so just be careful with that. All right, minus. Oh yeah, that was just like the quiz review. 1/6 x cubed plus. Now you would want this to be 1/5 x to the 5th. So you have to do a 5th times a 16th is 1/80th. Very good job. Now we're going to do upper minus lower, but you actually get to ignore 0 because if you plug 0 into all that, just 0. So basically just plug in 2. Does anyone know 2 to the 5th? We'll count on our fingers if we need to. 2 times 2 times 2 times 2 times 2. Just throwing it out there. 32. Good job. Awesome. Let's try one more and then I'll give you a break. It says the base of a solid is the region bounded by one arch of sine of x. So can you just make this be scaled by pi over 2? Can you just change that so it's by pi over 2 since we're going to do a trig function? And we're going to do sine. Welcome back to pre-calc. What does sine look like? Cool. Where does it start? If you get the starting point, you'll get the rest of it. 0. Good. Sine starts at the origin. Where does cosine start? What? Perfect. Okay. So start at 0 and then just go ahead and do a wave. It's going to look like this. And I'm not grading your art skills, but make an attempt to make it a nice smooth curve. It shouldn't look like a jack-o'-lantern mouth. Like it shouldn't look all jaggedy because it's differentiable. Oh, go ahead. Now it says one arch. So I guess, there's an infinite number of arches. I would choose this one now. They're all the same amount of area, so it really doesn't matter, but choose, the easy path. What shape is it that we have here?
Equilateral.
What shape is it? Okay, what does equilateral mean? All the sides are the same. And that means all the angles are the same too. Is it perpendicular to X or Y? They will come right out and tell you X. Okay, so that means your infinite slices loaf of bread goes this way. And the base of your shape is going to either be upper minus lower or right minus left. In this case, it's upper minus lower. So what is the upper graph? Sine X. And what's the lower? 0. So just sine X. And that means all the sides of this are sine X. You don't have to write it 3 times unless you really want to. I'm just trying to illustrate that they're all the same. So let's try and set up our integral. It's going to be dx. So the boundaries should be x values. And everything in there should be x, and then a dx at the end. So what do you think for your boundaries? Yeah, 0 to pi. Perfect. Leave a space and put dx. Now inside of there, you put the area of whatever your shape is. A triangle is 1/2 base times height. Now the base is sine of x. We are going to have to fight to get the height, all right? So bring your height down. I'm going to call it h. And look at just this side. Do you see how it's a right triangle? That means we can do Pythagorean theorem. What is this amount worth? Let your instinct kind of kick. Good, it's 1/2 sine x. Now, this is going to look messy, but it's not actually going to turn out all that bad. Okay, so you're going to have to just trust the process for a second. We're going to do Pythagorean theorem. So it's going to be h squared plus 1/2 sine x squared. That's these two sides equals hypotenuse squared, sine of x squared. So now we're going to square everything. What is 1/2 squared? 1/4, good. And sine of x squared is sine squared, yeah. Equals sine squared. That's why we put the 2 where we put it. The sine is being squared, not just the x. It's the whole function. Now we're going to subtract this to the other side. If you have 1 of something minus 1/4 of that something, you have left 3/4. Good job. And then your last step to get h by itself, which we're going to put it right here. We want our height right there, is to square root. Okay. What is your square root of 3? Square root of 3. What is your square root of 4? Oh my gosh. Not the square root of 3 over 2. Isn't that absolutely crazy? Wow. It comes from the unit circle. And then what is your square root of sine squared? Yep, just sine. This is one that we would put in the calculator. Do you see the difference? Reasonable? Not reasonable. Do you see the difference? Okay. Oh, whoops. I don't want to minimize. Just want to bring up my calculator and make sure that it's right there. Okay. Well, I need to make sure I'm in radians. You usually are, but it's always good to check. Okay, I'm in radians. I'm gonna type what? NT 0 to pi, you can just type pi. Parenthesis, we want 1/2 sine x. Oh wait, isn't it? No, just sine x, right? Then in the other one, square root of 3, 2 sine x, parenthesis. Perfect. There you go. 0.680. Yep, you need the 0 there though, because you need 3 decimal points. So the base of a solid, again, we're finding volume of a 3-dimensional thing, is bounded by these graphs. All right, x cubed plus 1. It's your cubed graph moved up 1. So you're going to start at 0, 1. And you're gonna have these points on either side, so it sort of looks linear, but what does the cubic graph look like? Yeah, like a wiggle, so just make it wiggle to the best of your ability. All right, y equals 0, that's just the x-axis. And then x equals 1 is a vertical line at 1. So you get this thing that looks sort of like a Hershey kiss, like half of a Hershey kiss. Again, that's not it though. You can't see it. You have to imagine it. Shapes are popping up out of the paper. What shapes are popping up out of the paper?
Rectangle.
Rectangles, and their heights are 2 times the width. So it's going to be taller than it is wide. So something like that. I don't have paper that will actually make shapes pop out at you. Okay. Now it says perpendicular to the y-axis. This is going to be a dy problem, and your slices in your infinite loaf of bread are all sideways. So we're going to do left minus, oh, sorry. Oh my gosh, I can't believe I just did that. Dyslexic moment for a second here. I am so sorry. Right minus left. Right minus left. Sorry, I get directionally challenged sometimes. Right minus left. For how upset I got the day I messed something up. Almost did it again. I was going to really beat myself up over that one. Messing up left and right. Right minus left. All right. As soon as you realize that it's sideways, you have to go back and rearrange this equation because it needs to be x equals instead of y equals. It's going to take 2 steps of work. What would you do to start getting x by itself? Yeah, -1. Good, perfect. Oh. Yeah, x cubed equals y minus 1, and then cube root. So x equals cube root y minus 1. And again, please circle that. I don't know why, but I've found that circling that just helps. It reminds you what goes in your integral. So for the base of your shape, we're going to do right minus left. Which graph is the right graph? Because it's actually not 0 this time. 1, good job. 1 is your right graph minus the whatever we just found. Yeah, good. Because your brain doesn't actually say it. It's just like that thing. So it's 1 minus cube root y minus 1. It's right minus left. Now the height of your rectangles is 2 times that. Okay, so it's 2 times what we just said. So now we're ready to set up our integral. Your boundaries have to be y values. Everything in there has to be a y and then a dy at the end. So using your y-axis, 0 to 2, good job. Inside of there, you put the area of your shape. So how do you get the area of a rectangle? Base times height. Now that's going to be 2 times this thing squared. And I am going to write it as squared. You know how you guys asked me on question 1, well, couldn't we write that as squared? And I was like, you could, but we're going to do this one by hand. We're not doing this one by hand. I'm putting this in the calculator, okay? So understand the difference between reasonable to do by hand and complete disaster. Okay. So you guys watch, make sure I don't type it wrong here, because if I type it wrong, the whole thing is wrong. All right, 2 parentheses, 1 minus cube root. So for cube root, I just type CBRT. That's kind of like the abbreviation. It's also down here in this menu. You can find a cube root. Y minus 1 squared, parentheses, y. 3.4.
That's pretty.
It is pretty. Now, again, remember, what you found is the volume of that object that you can't see except in your imagination. All right. Number 4, base of a solid is the region inside this circle. We're going to review circles real quick because you haven't done this since geometry, which was how many years ago for you at this point? A lot. So your radius is the square root of whatever that number is. That's why it's a perfect square. So your radius is 2. So from the origin, you're going to go 2 in each direction and then draw a circle. That's the base of the object that you can't see because it's in your imagination. What are the shapes that are popping up out of the paper at us? Okay, that's a lot to unpack. That's a lot of vocabulary. What does isosceles mean? Perfect. That means it's a 45, 45, 90. Coming with me? Okay, now there's two ways it can turn out. Oh, I ran out of sticky notes. Here, these are the two options. Nah, that's okay. I'll just write on the back of here. Either the hypotenuse is on the bottom or one of the legs is on the bottom. Do you see how those are your two options? It has to tell you. So just read. It says what is the base of it? The leg. Okay, so it goes this way. And the one of the legs of it is the base. Perpendicular to x-axis. So it's a dx problem. It's right side up. This is how your slices of bread go in your infinite slice. And the base of your shape is going to be upper minus lower. This actually looks really bad to start out with, but it ends up being okay. We'll be able to do this one by hand. You're going to have to just trust me. Okay, trust the process. We have to separate this into the upper graph and the lower graph. So what would you do to start getting y by itself? We're going to have to take a detour and do some algebra. Yep, minus the x squared. And then square root. Now, when you square root, you get a plus and a minus. So your upper graph is the positive square root, and your lower graph is the negative square root. It's like above, yes, exactly, like the top one and the bottom one. Yes, exactly. It's the above and below sea level. Perfect. So for the base of your shape, when you go to do upper minus lower, it's going to look like this. You have square root of blah, 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 minus the lower one is negative square root of blah, blah, blah. And so what happens to the negatives? They cancel. And if you have something plus another of that same something, you have two of them. Good job. Thank you for coming with me on that. 1 plus 1 is 2 is what we did there. Now we're ready to write an integral. They need to be x values. So look at your graph. Actually, you can't mess it up because it's a circle. It'll go from where to where? Yeah, -2 to 2. And inside of there, you put the area of your shape. So how do you get the area of a triangle? Yep, 1/2 base times height. The base is this, 2 square root of stuff. And what's the height? Why is it the same? Because you're correct. Yeah, it's isosceles. Good job. They're the same. So the 1/2 and one of the 2's is going to cancel. We can cancel those out. What else is actually going to cancel? I'm just going to simplify this here because yeah, square root of 4 minus x squared times square root of 4 minus x squared is actually just 4 minus x squared. And then what can you do with the 2? Yeah, distribute. Actually just doing a whole big lot of algebra. And now we're going to do some calculus, which is an antiderivative. So what's your antiderivative of 8? 8x minus 2/3 x cubed such that -2 to 2, and we'll just leave this alone. Just plug in the upper one minus the lower one. Two cubed is 8. 8 times 2 is 16. So that's why it ended up being 16/3. You could simplify that further, but I like at that point. We did it. Yes, I like that. We did it. Good job, us. One more. I tried to do an example of every shape that you could come across. So let's go ahead and draw these graphs. This is a parabola. What's been done to it? Flipped up 1. Good job. This is also gonna look like a parabola because it's an even power. It's just like a little bit more stretched out, but it went down one. And so it's gonna look like this. We're only looking at a very small piece of these graphs. This is sort of the only part of it that we care about. So what is your shape this time? Semicircle. And we are perpendicular to what? Good. So it's right side up. Yay. It's going to be dx. So the base of your shape is going to be upper minus lower. So which one is the upper one? Yeah, that one, right? This one. 1 minus x squared. Minus the lower one, which is the x to the fourth minus 1. I would go ahead and just do the algebra for that, distribute the negative combined like terms before we go ahead and like start trying to write an integral. 1 plus 1 is 2 is what we're doing there. So it's going to look like that. And then you're ready to set up an integral. As a heads up, do you think we're going to work this one by hand or put it in the calculator? This is going to be in the calculator. Okay, so we're going to set it up and then you guys can watch me type it in, make sure I don't do anything wrong. All right, boundaries need to be x values. So where to where? -1 to 1, dx. Inside of there is what? Good, perfect. Area of a semicircle is 1/2 pi r squared. Here is the most common mistake, is people take this and copy it in there. That's not the radius, it is the diameter. So you have to take that and have it. I 100% get why people forget to have it, because there's another 1/2 right here and you feel like you already did it. But what is this 1/2 for? Yeah, like the fact that it's half of a, like that's part of your formula. All right, this one's a doozy to type, so I do need for you guys to watch and make sure I don't mess this up or it's gonna be wrong. All right, let me get rid of that. Wait, stop. Pay attention. All right, what is this? 1/2. Hi, if you are not listening to me. 2 minus x squared. X to the fourth. And then I have to highlight all that. Divided by 2. Squared. Yeah, there we go. 1.934.
We're done.